Hello po, magandang gabi po sa inyo lahat mga kawerpa. Good day everyone. Welcome to MTHT Review and Training Center. Magandang araw po sa inyo lahat mga kawerpa po namin, and also to our Facebook viewers, no. Welcome everyone, no. We are Marina's Powerhouse Team Review and Training Center. We are conducting this free REE and RME mentoring program. No? This is actually a mentoring program, no, for electrical students and also reviewees who will take up the licensure exam. No? And this is also helpful to our electrical students around the world. No? So we will be uploading this video. No? From time to time, I'll be speaking an English language so that we can also please our electrical students around the globe, no? So please bear with us, no? So my name is Engineer Reggie Marinay. No? You can call me Kuya Reg, and I am a Filipino. No? So I have to apologize before we start. No? I am not that fluent in speaking English language. No? I'm a Filipino, so our language here is there's so many dialects in our country, no? And our national dialect here is Tagalog, no? Or more realistically, Taglish. It's a combination of Tagalog and English. So from time to time, I'll be speaking English language so that if there are, no, maybe not now, no, in the near future, somebody will take a look at our video, no? So they can make use of this lecture, not only for Filipinos. Okay. So this mentoring program actually is brought to you by UN Television, no? And Marina's Powerhouse Team Review and Training Center with their cooperation, no, in giving these public services, these free services, no. The MPHT Review Center has so many free programs, no. We have this free mentoring program. We also have free webinars, okay, with a special topic. We also have scholarship program, and we have a free electrical engineering and master electrician review on selected subjects. No, we'll be doing that. We've been doing this, no, since June of this 2020. This is via Zoom, no. This is actually an online program, no. So we are giving this for free to everyone, no. So okay, so that's it. Maybe we could start, partner. Okay, let's go now with our first question for this mentoring program. Okay, our first question came from, again, sa ating suki na, galing na mismo sa ating suki. Okay, kay Mr. Jonel Tepait. This is his question. Is he connected, partner? Yes. Hello,
yes,
sir.
Yes, po.
Good day.
Good evening. Good evening.
Good day. Good evening. Okay. Good evening, Sir Jonel. Okay.
Yes, po.
Okay, guys, we are actually live, no? We are actually live. So today is, what's the day today?
December 1.
December 1. Okay, so this is the first day of December and approximately 5:45 p.m. Philippine time. Okay, so let us have the first question. Okay, let us read the first question. A 400 MCM cable has 37 strands. What is the diameter, should be of each strand in mils? What is the diameter of each strand in mils? So we are given a choices here. Okay, so let us solve this problem. Okay, we are given here 400 MCM. 400 MCM. Okay. So 400 MCM. The 400 MCM is equivalent to 400,000. 400,000 cm. No? Okay? Remember, we have 1,000 here. Okay? The 1,000 signifies the M. This is actually a Roman numeral number. A Roman numeral. Okay? Just like if we have B, that is 5. If we have X, that is 10. If we have C, that is 100. Okay? So, if we have 1,000, you have letter M, meaning that is a kilo or 1,000. Okay? That is why, if we see 400 MCM, CM is what we call the circular mean. That is the area of a conductor, no? In circular mean. So that is also equal to 400 kc mil. Usually in the National Electrical Code, you will see this, 400 kc mil. The 400 kc mil, meaning they are just equal with MCM. The kc mil is just equal to the MCM. C mil is circular mil. The K is in kilo, just like our M here, which is 1,000. Okay, so what is circular mil? A circular mil is a unit of the area of a conductor that has a formula of d squared. That is the formula. Wherein our d here is expressed in mils. If we are to square the mils, you will get now the circular mils. Okay? So, in our problem, we are given here 400,000 circular mil. It has a 37 strands. Okay? See, there are around 37 strands here. That is the number of strands. There are so many strands here. Okay? There are strands of conductor here. Okay? There are so many. Okay, that's around 37 strands. You have 400,000 circular mil for 37 strands. Let us get the area per strand. The area in circular mil per strand. So that is equal to, we have 400,000 circular mil. So what is the given there, partner? So it is 37. 37. There are 37 strands, conductor strands here. Okay, that's given. Okay, approximately. Let's say you have a 37 strands here. So let us divide this. So we have 400,000. Then divided by 37. So that is equal to, we have 108.81. 108.10. 108.10.81. So this is the circular mil. That is the circular mil per strand. If we mean strand, that is a single conductor. Let's say this is a single conductor. It has a certain area. So this is that area, which is 10,810 circular mil. Okay? And that circular mil is equal to d squared. D squared. So we have here d squared. Okay? So let us get the square root of this value. So to get our d here, 10,810, 810.81. Let's get the square root. So that is equal to, so our answer here is 103.975. And that will be in mils. That will be our answer. Okay? So that will be in mils. See? That will be in mils. Okay, so therefore, my answer to this question, okay, Sir Janelle, my answer here is letter C. That is my answer to your question. Approximately letter C. That is nearest to letter C. Okay? So the 37 signifies the number of conductor here. No? They are in one cable. If we mean a cable, these are assembly of many conductors or wires. Okay? So you just have to divide it by the number of strands and then get the square root. You will have the quotient here, just get the square root, you will have this value. So our answer is letter C. Approximately, this is 104 mils because the question is the diameter of each strand in mils. So that is my answer. Sir Jonel,
Yes po, clear po.
104. Okay ba?
Yes po, clear po. Thank you po.
Okay.
Kawil pa. Yes po, clear po. Clear. Thank you, salamat.
Thank you, thank you. Salamat po.
Yes.
Like Polstra said, Coach Polstra said, salamat po. Thank you.
Thank you.
Okay, so again, huwag ka muna lumayo, Ka Junel. Meron pa. Ito yung pangalawang tanong na pinadala mo. There's a second question by Sir Junel. Okay. This is his question. Let us read his question. A 250 volt, 6,600 volts, 50 hertz single phase transformer has a core section of 600 square centimeter. The flux density in it is 0.707 Tesla. Determine the number of turns in the primary windings. So what is the number of turns in the primary winding? Because you have a transformer. So that's step up, step down. That is a step up transformer. No? So let us consider you have your transformer here. Okay. That is your transformer. So we have here your coil, primary coil. Then you will have here your secondary coil. Now basically it has more turn. This is the primary and this is the secondary. Because our given here is, how much is that? 250. That is the primary. 250 is to how much? 6,600. 6,600 volts. Meaning, the 250 here is the primary side of the transformer. And the 6,600 is the secondary side of the transformer. So we have the frequency 50 hertz. We have single phase. You're given the cross-sectional area of this core. This is the primary, secondary winding. Then we have the core here. Okay, and the flux density. The flux density is the magnetic field flowing here. Let's say we have a mutual flux here. Okay. You know the basic operation of a transformer. So I'll explain to you first the basic operation of a transformer. So we have here a primary source. Then we have a load here. We have a load. Okay. As we impress a voltage here, let's say we have a voltage of 250 volts here. So let's say this is our E sub 1. E sub 1. The secondary voltage is E sub 2. Okay? As we impress a voltage here, there will be current flowing here on the primary side of the transformer. So let's say this is our I sub 1. As the current I sub 1 flows in the winding of the transformer, it sets up a magnetic field in the coil. Always remember Ampere's right-hand rule. This is the current, this is the direction of the magnetic field. As the current flows in this coil, it sets up a magnetic field here. There is a magnetic field here, somewhere here. There are magnetic field flowing here. Okay? There are magnetic field here. As the current flows in our primary winding, it sets up a magnetic field. Then this magnetic field creates a magnetic flux that will flow in the air and that will flow in the core. So this is the transformer core. And this core will flow from the primary, this flux, this is the magnetic field. There will be a magnetic flux here. Due to the current I sub 1, there will be magnetic flux that will flow in the air and in the core. The core, the magnetic flux flowing from the primary going to the secondary winding, that is actually encircling in the core. No? Paikot-ikot yan dyan. No? So, that is the mutual flux. That is the flux that links the primary and the secondary winding here. Okay? As it flows from primary going to the secondary, this induces a current here. Okay? That induces a current in the secondary coil. This magnetic flux. This magnetic flux. There will be an interruption here. There will be a cutting of flux or induction here on the secondary side. That produces our E sub 2. Then our E sub 2 here, no, is an induced voltage on the secondary side. So you will have here your current I sub 2. So therefore, your I sub 2 here will flow through the load. Okay? So, we are given here, we have a primary number of turns, N sub 1, then we have here our N sub 2. Okay. So we have what we call the transformation ratio. Ratio of transformation ratio, just the same. Transformation ratio of the transformer, okay, indicated by letter A. And our transformation ratio A is equal to this formula. So I just call this as any, E-N-I, any, E-N-I, any, E-N-I, any, 1, 1, 2, 2, 2, 1. Okay? That is any. Any. 1, 1, 2, 2, 2, 1. So that is any. Now, take a look here. Take a look here. If this is 1, this is also 1, then 2, 2, meaning they are directly proportional. What do we mean by directly proportional? As the number of turns increases, okay, as the number of turns increases, meaning you have more turns, meaning you will have a bigger voltage. Mas maraming ikot ng wire, mas mataas ang voltahe doon. If you decrease the number of turn, the voltage also decreases. No? Konting ikot, konti rin ang voltahe. No? Then take a look here. Take a look here. What about the relation of the voltage to the current here? What is their relationship? See? Their relationship is different. This is 1, this is 2. This is 2, this is 1. So meaning they are inversely proportional. Meaning, if you will have a large current on the side of the transformer, meaning that side has a low voltage. Low voltage. If you have a low current side, meaning that is a higher voltage side. What do I mean? Let us have a practical example. Let us consider you have a three-phase system, even if it is a single phase, just the same principle. You will have a three distribution transformer here. You have three distribution transformer that is connected to the distribution line here. Okay, that is connected line at phase A, phase B, and phase C. Then this supplies a certain restaurant. Question, which has a larger size of wire? Is it the primary or the secondary side? Saan mas malaking size ng wire? Primaryo, sekundaryo? Saan mas malaki? Mas malaki sa secondary side. Tama. No? Now, this secondary side is actually low voltage side, but it is high current. Why? Because this has a bigger size of wire. When you are sizing a conductor, if you size a conductor, it depends on the ampere. If you are sizing an insulator, it depends on the volts, on the voltage. That is why an insulators, they are expressed in volts, not amps. Okay? Oh, by the way, no, to all our viewers, no, in our Zoom class in particular, no, you may send in your question. I will answer live question later. If we still have time, you may type your question in the Zoom chat, no, in the chat board. Then I will answer your questions later. Okay? Or maybe you will have your follow-up question regarding to those topics I've discussed. You can have a follow-up question. Okay? Then later, I will answer that. Maybe around 6:45 p.m., I will answer those questions. Okay? So let us continue here. This has a larger size of wire. A larger size of wire will have a higher current, will have higher current side, but it is low voltage side. So meaning, the primary of your transformer is high voltage side, but it is this high voltage, but it is low current. One sample voltage being used by the utility company is, a sample is, let's say, 34.5. Oh, sir, that's very low. No, it is kV, kilovolts. Okay? That is in kilovolts, not in volts. Meaning it is 34,500 volts. Okay? That is the line-to-line voltage on the primary side. Then on the secondary side, that is approximately 230 volts, which is the nominal voltage of the utility. Okay? So, in transformer, if you have the low voltage side, automatically it is a high current side. It is inverse. They have an inverse relation. If you have a high voltage side, meaning that is the low current side of a transformer, I am referring to the transformer, not the Ohm's law. Okay? Sir, I think it's a conflict. When we were in third year college, you said that as the voltage increases, you see, take a look here. You said that as the voltage increases, the current also increases. As the voltage decreases, the current also decreases. You said this when we were in third year college. But now you are saying we are now already in fourth year. You are saying the current increases, the voltage decreases. How is this? How is this? Because in third year college, no, when you were in third year, you are just studying Ohm's law, the direct current circuits. In direct current circuits, of course, our formula is I that's equal to V divided by R. Of course, the relationship here, as the voltage increases, the current also increases. There is no transformer involved. There is a direct connection. Take a look here. There is a direct connection between the source. Let's say it has a variable DC source. So you will have here a load. This is how we experiment this in the university. So you have the load here. You have your ammeter here. And you have your voltmeter here. See? As we increase the voltage from the source, let's say this is the voltage, we increase the voltage here. Of course, the current will increase also. Okay? That will also increase. There is a direct connection of the source to the load. But if you are going to use a transformer, that will be in between your source and the load. It's a different thing. You have to consider the transformation function of the transformer, because this transforms without changing the power. It doesn't change. If you have a power here, let's say of 300 kVA, this is also 300 kVA on the secondary side. Okay? That is a transformer. It doesn't change the power. It doesn't change the waveform. Okay? Doesn't change. Okay? So, speaking of a transformer is a different thing. If you increase the current, meaning there is a low voltage. If you have a low current, there is a high voltage here. It's a different thing. That is the difference between the Ohm's law and the transformer. Okay? In the transformer, they have inverse relation. In the Ohm's law, they have direct relation between the voltage and current. As we increase the voltage, the current also increase. See? In transformer, it's different. If you have a high voltage, you have low current there. Okay? So we have to be very specific. Now, so anyway, that is just some transformer principle. Now, the question is the number of turns on the primary side. Okay? So we have to introduce a formula. What is the formula in getting first? Let's get first the induced EMF. I'll give you this formula. This is found in so many textbooks, okay, in electrical engineering. So that is 4.44 frequency, flux, and then N. Okay. Remember, if I'm going to make this as 1, this should be 1. Primary, primary. This is the number of turns, the N. If I will make this as 2, make this also as 2, meaning secondary voltage. Okay? So, let us calculate this. Let us calculate this. This is a basic formula now. You have a basic formula here. Okay? So, we have here a magnetic flux. We studied last week or last Sunday about the magnetism, magnetic flux, magnetic circuits. Okay. The magnetic flux density is equal to the magnetic flux over the area. Remember, in our problem, we are given the magnetic flux and the area. If we are to get our magnetic flux that is equal to the area, cross multiply here, that is multiplied by the flux density. That is what we call the flux density. This is the magnetic flux. This is the cross-sectional area. Cross-sectional area. Now, I will just substitute the AB to the magnetic flux here. So we have here E, that's equal to 4.44 the frequency, the magnetic flux, which is area, okay, multiplied by the flux density. This is what we call the flux density in Tesla, okay? And then this is the number of turns. All multiplication process here. Okay, I will make use of this formula. This will be our working formula for this problem. Okay, so we have here primary, and this is primary. Remember, the unknown is our N1. So our N1. What is our E1 in the problem? Our E1 is 250. So I will just put here 250. So we have here a constant of 4.44. 4.44. So we have here the frequency. How much is the frequency given? Let's see. Ilan ba yan? 50 hertz. That is the frequency. 50 hertz. Then what about now the area? The area we have, how much is that? 600. 600, this is 600. Remember, the 600 is in square centimeter. We are speaking of metric system here. In metric system, the area to be considered must be in square meter. It must be in square meter. So let us do some conversion here. In 1 meter, there are 100 centimeter. Then we have to square this also because this is square. Okay? Okay. So that is for the area. So that is for the area. Times the flux density. What is the flux density? 0.707. 0.707. Remember that the unit is in Tesla. Tesla. 0.707 Tesla. Then we have here our N sub 1. Okay. Well, you will see here that the only unknown is N sub 1. This is very easy in our calculator. Just use the shift solve. No? Okay. So I will calculate this. How much is this? Remember, this is 1. 1 squared simply 1. But there is 100 here. What is 100 squared? That is 100 times 100. I think that's 10,000. That's 10,000. Okay, let us manipulate this. So we have 250 alpha calc 4.44 times 50 times 600. Okay. 600, then let us consider the 100 x squared, then multiplied by 0.707, then multiplied by the N1, or just simply make it the alpha close parenthesis to declare as x. No? So we have shift calc equals. So this will be our answer. Our answer here is this. N sub 1 will be equal to 26.547. 547 turns. That is approximately, let's take a look at the choices. What are the choices? Okay, the answer would be letter A. Nearest 26.547. That is nearest to letter A. Sir Junel, no? That is my answer to your question.
Yes po.
27. There you are. No?
Thank you po. Thank you.
Okay, Sir Junel, that is my answer to your problem. To your
Yes po.
question. Thank you. Thank you.
Thank you. Thank you.
Okay. Okay, let's go now to the next question. Next question is given by Mr. Alan. What's his surname? Maybe it's better if there is a surname. Is he connected, Alan?
Yes po, sir. Yes po. Sira po yung camera ko, sir, kaya hindi pa ako makapag-open kami.
Oh, you don't have a camera?
Pag binubuksan ko po, nakikita ko naman po yung sarili ko, pero pag tinitignan ko po sa participant, naka-off cam po ako.
And can you open, is it possible that you open your camera? Alan, there.
Naka-open na po yung camera ko, sir. Nakikita niyo po ba?
Okay.
Or
Okay, I saw you now. I saw.
Okay po.
Do you hear me, Alan? Do you hear me?
Hello po. Yes, sir. Yes, sir.
Do you hear me clearly?
Yes po.
Do you see me in the video? Do you see
Yes
me?
po. Yes po.
Okay, you see everything, huh? Okay. So I will answer your question. Your question here is if the voltage rotation of a three-phase motor is A, B, and C, the current rotation is blank. Actually, I have already a discussion here, no, about the symmetrical component or, well, anyway, your question here is only about this what we call actually a phase sequence. I will just discuss the phase sequence, no, because symmetrical component is too long, no. I already have a discussion about that. Or maybe you can go back to my lecture about the symmetrical component in our playlist, no? But just to answer your question here, so please listen carefully, Alan. You are given a three-phase motor. Three-phase motor. Let's say you have a three-phase motor here. This is your three-phase motor. Okay. So you have here your all three-phase motor has what we call three terminals, designated as T1, T2, and T3. Even I have a discussion about the motor standard markings, standard connection and terminal markings. No, you can go back to my lecture. I even have a long lecture, more than 2 hours, 3 hours lecture about the motor principles and standard connections. You can take a look at my playlist in my webinar in my channel. Okay. So this is phase A, phase B, and phase C. There are two types of phase sequence. We have what we call the positive phase sequence. And we have what we call the negative phase sequence. This is the reason why you have to consider the phase sequence. If you want to change the direction of rotation of a three-phase motor, you have to consider that. There is a board exam question in the registered electrical engineer and registered master electrician. There is a question: how to reverse the direction of rotation of a three-phase motor. I'll give you the answer now. Interchange any two leads. Interchange any two leads. You have three leads here. You have to interchange any of the three leads. You may interchange AB or BC or CA. You may do that. You may do that. Okay? So, by the way, what is a phase sequence? What is a phase sequence? Let's take a look here. Let us consider we have a phase sequence. here. Let's say you will see here that there is a current flowing. You will have here your IA. You will have here your IB. You will have here your IC. What is a phase sequence? A phase sequence is the order in which the currents and the voltages comes to their respective values. Let's say you have your IA. You have your IA or EA. It can be IA, it can be current, or it can be voltage. Let us represent this as this one. So let's say this is our IA. Or let us designate this as simply A. It can be voltage, it can be current. A. Then, you have your 360 degrees. There is a phase displacement between each phases. If I mean phase, these are A, B, and C. 360 degrees divided by 3. So you will come up with a phase displacement of 120 degrees between A, IA, IB, IC, or BA, BB, or BC. Okay? This is our IA. And then after, we all know from this point up to this point, this is 180 degrees. And this is also 180. So from the origin going here, that is actually 360 degrees. Okay. We have here a sine wave, meaning it changes from positive to negative. This is the magnitude of the current, let's say. There is a time it is 0. There is a time it is maximum, positive maximum, negative maximum. Okay? That's why the current moves back and forth. Okay? Maybe you can take a look at my basic AC circuit discussion, no? In my one of my webinar. So, you will have here your phase A. What about for phase B? After 120 electrical degrees, or 120 degrees here, 180, this is something like this one. So this is phase B. Our basis is the starting point of the waveform. This is the starting point. It is the point wherein the next point is going to the positive direction. What about here? This sine wave. That sine wave, it has this starting point. So their phase displacement is 120 degrees. This is 120 degrees. From this point up to this point. I have to apologize to our electricians. This is quite a deep study because this is being discussed in electrical engineering. I think around third year or fourth year in college. Okay. So, well, anyway, if you have a theoretical background, there is no problem. So, don't worry, I will make it easier for you to understand also. Because there are some electricians, we have some participants who are electricians. Not all of our participants are electrical engineering students or graduates. No? So we have some electricians there. Some of them took up vocational study or technical school. No? So, well, this is an advanced study for you, not unless you will enroll to our master electrician review. Okay. So let's continue this. This is phase A, phase B. Now, what about now for phase C? This is the phase C. After another 120 degrees, there you have. This is your phase A, B, C. See? What does it mean? The current will flow first is IA. And remember that degrees, this is again 120 degrees. This is 120 degrees. Okay? That is the phase displacement between the phases is 120 degrees. A degrees is a unit of time. Remember, no? It is a unit of time. Okay. I hope you understand. I can answer directly the question for 10 seconds. But you do not know the principle. What's the sense? There's no sense. If I am going to discuss in a detailed manner, I can answer not only one question. Kumbaga, marami nang nakapalaman dyan. No? Ano ba sa English yun? No? Marami nang sinasagot na tanong yan. No? If I answer one question, I am answering so many questions there already. Because I am discussing the concept or the principle. Let's continue. IA first will flow. And then IB, after 120 degrees, it will start to flow. And then IC will flow after IB, after 120 degrees also. You know, phase sequence, from the word sequence, whoever comes first, the second, and the third one. May pagkakasunod-sunod. Okay? By the way, you can type your if you have any follow-up question, you may do so. You can type to our Zoom chat there. You can type there. So, huwag mo muna papakita yung partner. Ha? Pipili ako. Okay. So, we have here positive phase sequence. What is positive phase sequence? The one I've showed to you is positive phase sequence already. This is positive phase sequence already. What about, sir, the negative phase sequence? The negative phase sequence is this. Just reverse. No? Baliktarin mo lang yung C at saka yung B. That is already the negative phase sequence. What do I mean? Let us have a vector analysis or a Phasor analysis. This is a Phasor analysis. For positive phase sequence, we have A here. We have B, then we have C. A, B, C. For negative phase sequence, we have A, we have C, we have B. You see, B and C, they change their position. See, nagbaliktad sila. I will have here a guide. Let's say the red one. You see, the red line here is my guide. My reference line, I should say. Let's take a look. Let's say this is our phase A. This is phase B, the red one. We use red. And this is phase C. You see, there is actually their phase displacement here. These are 120 degrees. Okay, these are all 120 degrees. The distance of A to B, B to C, C to A are all 120 degrees. Actually, this is an introduction to the symmetrical components, what we are doing here right now. It's a fourth-year subject in electrical engineering. Okay, so we have A, we have C here, then we have B. Let us assume, let us think of this is a fix. Okay? So, fix to ha, fix. Sabihin, hindi magagalaw. See? This is A, this is C, and this is B. They are fixed 120 degrees. I will rotate this in a counterclockwise direction. I will rotate this. Who touches first? The red line. Is it A, B, or C? A, right? Secondly, who touches B, right? Then what about C? C, it's quite hard. C, right? So, you will have here as A, B, and C. See? That is A, B, C. What about the phase sequence here? What about here? So, we have here phase A, the black one. The red is B. Then we have the C here. Oh, the B is the red one. The C is the blue one here. Okay, take a look. I will rotate this. Who touches first? A, isn't it? Okay, Mark Anthony, you answer. You'll be the one to answer so that we have an interaction.
Yes, sir. A, sir.
Hindi, si ano na lang. Si ano pa lang nagtanong eh. si Alan, ano? Sorry, Mark Anthony, mamaya ka na. Okay. Si Alan na muna. Alan, hello.
Hello, Kuya Reg.
Okay.
Hello po.
Who touches first? Sino unang tumama sa reference line? Pak, sino unang tumama?
Si A po.
A. Then, secondly, who touches?
Is C po.
C.
Ay, blue, yung blue po.
Okay, that's correct. The third one. Make it pass. It's hard.
Si B po, red.
B, right? So, we have here ACB. Right? ACB. Now, Alan, take a look here. I will repeat this. ABC, ABC, ABC. That is a positive phase sequence, right? What about for negative phase sequence? I will repeat this. ACB, ACB, and then another ACB. Remember this, Alan. ABC is equal to BCA is equal to CAB. Did you see that, Alan? I will write it down.
Yes po.
ABC is equal to what?
BCA po.
BCA is equal to CAB. Right? CAB. What about here? ACB, that's equal to BAC, is equal to CBA. Are you working, Alan? Are you working?
Yes po.
Yes. So this is the favorite of all employees, the CBA. Right? Collective Bargaining Agreement. There will be a lot of benefits if you tackle the CBA. Okay? Okay, now. These are negative. All of these are just the same. Negative phase sequence. All of these are just the same. Positive phase sequence. Positive phase sequence. They are just the same. I think I can answer now the question. Or maybe later. I want to make it as complete as possible, as I can. What is the relevance of this in changing the direction of rotation of a three-phase motor? What is the relevance of this? There is electrician. He will answer a student, an electrical student asking him a question. How to reverse, hey electrician, how to reverse the direction of rotation of a three-phase motor? That's easy. Just change any two terminals. Then you will see that it will move in opposite direction. Counterclockwise, it will become a clockwise rotation. The electrician will answer that. Oh, really? Yes, that's my answer. What more? Oh, that is my answer. That's my experience. The one asking question is an electrical engineering student. You have to know a deeper answer to it. There should be a scientific explanation. Take a look here. Actually, that is a correct answer. But if we dig deeper, interchange any two leads, what will happen now? Shall we say, I will interchange any two leads? Oh, by the way, first, let us prove that this is a positive phase sequence. This setup, this close up this portion. This is a positive phase sequence. Who touches terminal 1 of the motor? Who touches? Phase A. See A. Who touches terminal 2? B. Or simply IB. P3. C. Or IC. What about if I am going to interchange the two leads? I will make it as, I will interchange A and B. See? Who touches terminal 1? That is connected to what? I mean, it's already connected to B, right? Okay, Alan, you answer me. You answer me. So that we have an interaction here. Terminal 1 now is connected where? Saan siya konektado, Alan? A, B, C.
Hello po. Medyo chubby po. Chubby.
Where is it connected? The terminal 1 is connected where?
B po, sir. Sa
B.
B,
Okay.
phase B.
B. Terminal 2 is connected where? It is connected to
Sa phase A po.
phase A. Okay. Terminal 3, of course, still doesn't change. C. Take a look here. Take a look. We have here ABC. Before, we have ABC because that is positive phase sequence. No question about that. When we interchange A and B, so you will have here BAC, right? Alan?
Opo.
BAC. Take a look. But where is BAC now? BAC now is a negative phase sequence. Earlier, that is ABC, which is positive phase sequence. See? Now, it becomes BAC. You interchange A and B. What if I will interchange? I will interchange B and C. What will happen? I will interchange BC. There. Who touches A? Alan.
Doon pa rin po sa A, sir.
Of course, yes. Who touches B? I mean, terminal 2 of the motor. That will be now connected to
Phase C po.
C. Okay. Terminal 3 is now connected to
Phase B po.
B. So you will see here that there is ACB. Right, Alan? ACB. But where is ACB? That is in negative phase sequence here. You see? Earlier, it is ABC. Originally, it is ABC. Let's say the motor is moving clockwise. When you reverse any two leads, it becomes counterclockwise. What if we change A and C? Let's see what will happen. Ano mangyayari? Tingnan natin. So, A and C. There. C. Okay, lastly, Alan, terminal 1 now is connected to what?
Phase C po.
Phase C. Okay.
C po.
Terminal 2 is connected to
Sa B, phase B po. Doon
B.
pa rin po.
Okay. Terminal 3 is connected where?
Sa phase A po.
Okay, phase A. So you will see here, collective bargaining agreement, right? CBA. And CBA is found here on the negative phase sequence. You see, it's not only just interchange any two leads. Why it becomes a reverse in rotation? Because the phase sequence interchange. Because of the sequence of flow of the current. Kumbaga kasi may nakaka-apekto yung direksyon ng ikot ng motor sa sa yung sequence ng pagdaloy, yung pagkakasunod-sunod ng pagdaloy ng kuryente. No? Nakaka-apekto yun sa rotation. So, that is the effect of phase sequence to the motor rotation. When you change from positive to negative or negative positive, vice versa, because you are changing the phase sequence. Phase sequence is very important in rotating machinery. Okay? It's very important. It affects the rotation. If you have two generators, you have one generator, you want to connect another generator. Let's say you are in a ship, nasa barko ka, no? In the ship, in the watercraft, you have to parallel another generator. One of the requirements is they should have the same phase sequence. There is an effect if this generator already connected to the bus, then you connect, this is positive phase sequence, and you connect the negative phase sequence. The effect on this generator that may change the rotation of the shaft, and that may damage mechanically. That's one of the effects. Okay? Now, let's go now to the question. That's a very long discussion about the phase sequence. Okay. If voltage rotation of a three-phase motor is ABC. Okay. ABC, di ba? The current rotation is blank. Okay. You have a voltage rotation ABC. What is your current rotation? Remember, just like what I've said, this can be voltage or current because it depends. The current depends on the voltage. They have the same direction. Okay? They have the same. If you have voltage rotation, that is actually phase sequence. That rotation refers to the phase sequence. You have your ABC. The current rotation is blank. Okay. What is CBA for letter A? Alan, you'll be the one to answer. What is CBA based on what we studied? Alan?
Hello po, hello po.
What is CBA? Positive or negative phase sequence?
Sa negative phase sequence po.
Okay. Negative phase sequence. Our given is ABC. That is positive phase sequence, right? So therefore, we
Yes,
have to find positive phase sequence among A, B, C, and D. So let us eliminate letter A. Right? Alan?
Apo.
Okay, what
Apo.
is letter B? Letter B is BCA. I will go first with BAC, letter D. What is BAC, Alan?
Sa negative phase sequence po.
What? For letter C, we have ACB. What is ACB, Alan?
Sa
ACBA,
negative phase sequence din po.
what is letter B?
Negative phase sequence.
What is BCA?
Sa positive po.
So
Sa
therefore,
positive po. Positive sequence.
what is the answer?
Letter
What
B.
letter?
Letter B po.
Letter
BCA.
Okay, that's correct. No? That is the answer.
Apo.
Letter
Thank you po.
Okay, they are just the same. ABC is equal to BCA equal to CAB. These are all positive phase sequence. Okay? And ACB is equal to BAC equal to CBA. These are all negative phase sequence. Okay, is that clear, Alan?
Yes po. Yes po,
Okay.
clear.
That is my
Yes
answer
na po.
to your question. Thank you. Salamat. Dali. Huwag mo muna papakita yun. Tayo. Sige, pakita mo na. Sige. Okay, so we have another question, no? Just like I promised to you before, I think that was last Sunday. So I got this question from Facebook. Sino ba yung nagtanong yan? That question came from Dexter Jaime or Jaime. Okay? Electrical Maintenance Technician, Philippines, no? Why do transformers work only with AC, not with DC? Okay? Why do transformers work with AC, not with DC? Okay, there are so many answers can be discussed in this question. Why do transformers work in AC? Because transformer is an AC machine. I'll just give you a shortcut answer to this. Okay, a transformer is an AC device. It is an AC device. It is part of the alternating current machine. No? So it's not connected, partner. No? So because we just take this from the Facebook. Okay, transformer works only in AC, not in DC. I remember we had an experiment in our school as a professor in electrical engineering. We have an experiment in the laboratory. This is our experiment. There are two transformer coil. Say we have the positive, primary and negative, primary and secondary, I mean. There is a DC source here. Then there is a galvanometer here. This is like a meter in your automotive vehicle. In your car, I mean. You say this is 0. This is a positive and this is negative. Okay? The pointer may deflect on the positive or on the negative direction. We have a DC source. We have a DC source. So why do transformer works only with AC? Once you press this push button, you press this, what will happen? Once you press this, your inductor becomes short-circuited. Why? That is the transient behavior of an inductor. Let's go with the transient behavior of the inductor. At time t is equal to 0, and there is a time t is equal to infinity. At time t equal to 0, meaning this is upon switch. Upon switching. And this is you have switch is on, meaning your switch is closed, on or closed for a long time. I mean, sa Tagalog, babad. No? Sabi nga ng professor ko, babad. No? Our inductor behavior, T is equal to 0. Our inductor is open. Upon switching, let's say, upon switching, nothing will happen. Then, as it first touches for a couple of milliseconds or microseconds, since this is a DC source, this will become shorter. I have to prove this mathematically. An inductor has an induced EMF of L di over dt. That is the formula of the induced EMF in the inductor here. Remember, in DC, this is actually a change, or E that's equal to L, change in current with respect to time. Question: do DC changes its magnitude? Do DC changes its magnitude? Theoretically, it's not. Basically, it doesn't change. DC has a constant value, not unless your battery is being discharged, its value. At a normal condition, theoretically, it is linear. It doesn't change. There is no changing in the value of the current. Remember that the magnetic flux is dependent on the current. In this formula, if there is no change, meaning the final current, no? The final current minus the initial current is just the same. If they are the same, so that is the change in current. If they are just the same, is there any change? Is there any change? There's no change. Walang pagbabago doon. Pag DC, hindi nagbabago yung kuryente. In DC, current doesn't change. This is 0. That is why this change in current is 0. If this is 0, of course, the voltage will be 0. the voltage will be 0. Okay? And what is a 0 volt? A 0 volt is the voltage of a short circuit that is shorted. How is this? Let's say you have your AC source, AC or DC source, 230 volts. If you put a voltmeter here, what is the reading on the voltmeter? 230, of course, 230 volts. But what happened if we short line 1 and line 2? What will be the reading of the voltmeter? That will become 0. You have your 2 leads now. This will not be 230 anymore. Although you have a 230 source, that will just be 0. That is shorted, short circuit. That is the most dangerous thing that will happen to your electrical system. Okay? There, in DC, there is no change in current. I have to prove another thing. I teach this in the our topic last time in the electromagnetic induction, the Faraday's law equation. The Faraday's law equation is negative N, negative due to Lenz's law. This is the change in the flux over the change in time. Or mathematically, this is negative N, the derivative of the flux with respect to time. The derivative meaning that there is a change in flux. Question: if, since the magnetic flux is dependent on the current, if there is no change in current, is there a change in flux? Is there a change in flux? None. Walang pagbabago. Unlike in AC, remember in AC, that is a sine wave. And in AC, if you are to graph the magnitude, it is fluctuating. It changes, it varies its magnitude. There is a change in AC. But in DC, it's none. That's fixed. That's fixed. Straight line. In AC, there is a continuous changing in the magnitude and the direction. Pabago-bago yun. No? That is why there is no change. With this equation, I've shown to you, there is no change in current. Therefore, there is no change in flux. If there is no change in flux, this is 0. That E is also 0 here. Hindi gagana. No? It will not work. No? Okay? And the nature of the inductor, when you close the switch for a long time, that will just be short-circuited. What will happen? This will just burn. Masusunog lang to. No? Susunugin niya lang yan. No? Kaya hindi gagana yan. That is my answer to that question. Then there is another question, partner. Actually, I already answered this question last Sunday, no? But let's see, for the benefit of our new viewers, this question came from where? Thomas Torregosa, from Pinoy Electrician and Electrical Engineers. Meron bang polarity ang transformer? Para saan yon? Okay, I will convert this in English. Do transformer has polarity? What is the function? Where can we use that? This is a Facebook post. No? There are so many answers there. And some of the engineers or electricians, they had this answer. I remember. Well, you can go back with this group. No? Hindi naman namin kayo maluloko. Tingnan nyo, i-screenshot ninyo. Pwede nyo balikan yan sa groups. No? Pinoy Electricians and Electrical Engineers. There are some engineers or electricians answering, transformer has no polarity. It is because it is AC. AC has no polarity. I disagree. I disagree. Do AC has polarity? Sir, it has no polarity. In fact, you have your plug. You can connect in the plug any position you want it. That's why there's no polarity. Well, if that's the case, meaning that does that mean there is no polarity already? The question is, do AC has polarity? This is my answer. Actually, I have an answer before. Let's take a look here in our three-phase system. There is a sine wave. We have a positive, we have negative, right? Sometimes it is positive, sometimes it is negative. So, the question is, does it have a polarity? Yes, it has a polarity. Positive. There is a time it is positive. There is a time it is negative. So, AC has polarity. It's just that AC changes its direction and magnitude. Okay? Nag-iiba lang po yung yung polarity. Pero ang tanong kasi kung may polarity, meron. May polarity, kaya lang nag-alternate. Nag-alternate lang, wala nang polarity. Ano yun? Ang liwanag, nakasulat sa mga libro, may polarity. Okay? Ganda, may basihan tayo. No? Yan ang basihan. I will not talking without a basis. That is my promise to everyone. Well, you can consult some electrical engineering books to prove, no, what I'm saying here in our mentoring program. You can prove me wrong. Let's see. Okay? I'm challenging you. No? So for me, I believe AC has a polarity. It's just that it changes. So if AC has polarity, therefore transformer has a polarity. But how to put transformer polarity? Let us have an experiment. This is our experiment in the university. Take a look here. That's why I draw this figure. Let's close up this pattern. This is actually a continuation of the first question about do transformer works in DC. By the way, there is a special type of transformer that can be worked in DC. There is. That is what we call a pulse transformer. Pulse transformer. Just like the transformer being used in our charger. Well, that is a special case. Okay? That's a special case. But basically, transformer will not work in DC. This is what we call an inductive kick test. Inductive kick. Or shall we say method. We are going to determine the transformer point. Okay. Take a look here. We see here, let's say this is a step-down transformer. 220, 110 volts, let's say. You have a coil here. Okay. So, I will put the positive terminal of the battery here in this coil. Let's say this is also positive. This is negative. If you see this one, this is a dot. That is what we call a polarity mark of the transformer. Polarity mark. A transformer has a polarity because it has a polarity mark. That's one thing. No? This polarity mark of high volt, this is high voltage side, let's say, this is lower voltage side. This positive is polarity mark. If you see a polarity mark, you assume a certain instant to be positive. So, I will designate this as H sub 1. And this is our H sub 2. Now, sir, what about here? The lower voltage side. We designate this as X and X. But the question is, where is X sub 1? Where is X sub 2? That is the problem. This is what we call inductive kick method. Remember, we have a DC source here. This is a push button. It has a spring. So if I'm going to press this a little, okay, just momentarily touching the contact. Just a little, because this has a spring, this will just have a continuity once my finger is pressing the button here. Once I press this, pop, a little, pop, just a bit. You will see the response of the galvanometer here. If your galvanometer moves on the positive side here, meaning this is our X sub 1. The polarity mark is here. Remember that if you see polarity mark, that is 1. If there is no polarity mark, that is 2. Okay? Pag merong that, 1 yon. No? Okay? X meaning that is the designation of the lower voltage side. You will see that in the transformer. Even the distribution transformer in the pole, you will see X1, X2, you will see X1, X2, X3. Okay? You will see that. If this deflects on the positive direction, there you have your polarity mark here. Sir, what if this deflects on the negative direction? What will happen? If that is on the negative side here, okay, so our polarity mark will be here. This will be X sub 1. Of course, the polarity mark is here. This will be X sub 2. Baliktad siya. Okay? So you will watch this galvanometer, the response. Sir, what is the importance of this polarity mark? It's very important. I'll give you a basic discussion. There is 2 types of series connection. We have what we call the series aiding connection, and we have the series opposing. Series opposing connection. You see, in series aiding, take a look here. Let's say you have 2 transformer coil. This is 110 volts. This is also 110 volts. Question, what is the reading on the voltmeter? What will be the reading of the voltmeter here? Remember, this is just equivalent to 2 batteries connected in series aiding. How is this set? I'll show this with you. Okay, I will erase first the voltmeter connection here. Take a look here. Negative, positive. The polarity mark signifies the positive of the battery. Okay, negative, positive. You see, this is 110, 110 volts. If you have here your voltmeter, okay, what about the direction of the current? Here, conventionally, it must moves out or lives at the positive terminal of the battery. Well, you may watch my videos in my channel regarding electrical principles, no? So that you will understand this easily. So they have the same direction. They are aiding, meaning they have the same direction. They are helping each other. You can make use of the Kirchhoff's voltage law. What is the voltmeter reading here? This is positive, this is negative. That is just an assumption. Huh? We can have this It depends on your how you connect your voltmeter. Okay, we can also put this positive and negative. So we have here a circuit tracing. By Kirchhoff's voltage law, the circuit tracing moves out of the negative of the voltmeter. So that is negative. And this circuit tracing moves or lives at the positive terminal of this battery. Let's say this is 110 volts. So that is positive 110. And again, this circuit tracing lives, no? Doon siya lumabas sa positive ng baterya na to ulit. Kaya positive 110. That is equal to 0. Summation of any voltages is equal to 0 at any loop. That is our KVL, Kirchhoff's voltage law. 110 plus 110, 220. Positive 220. So therefore, the transpose B, our V now will be 220 volts. Or just simply, para hindi na natin mapahirapan, mangyayari, mag-a-add lang itong dalawa. Mag-a-add lang itong dalawa. What about the series opposing? If you have your transformer coil, here, on this direction. There. You have negative, positive, and then this terminal is positive, this is negative. Okay? And then, what is the conventional flow of current here? That is going to the right, and this is going to the left. You see, it is called as opposing because the two current opposes each other. Magkakontra silang dalawa. Diba? Nakita nyo na? Now, they oppose each other. 110 volts, 110 volts. Then, we have here a voltmeter. What is the reading of the voltmeter here? I will make this as negative and this is positive. I will have our circuit tracing for the Kirchhoff's voltage law. Take a look here. By Kirchhoff's voltage law, the circuit tracing lives on the negative terminal of the battery. That's why I put here negative P. What about here on this battery? Saan siya lumalabas? It lives on the positive terminal of the battery. Positive 110. What about here? This lives on the negative terminal of the battery. That's equal to 0. So you will see here that negative B, 110 minus 110 minus 110 is 0. Simply 0. Or just simply our B is equal to 0. Again, what is B equal to 0? That is just a short circuit. That is a shorted. Okay? Shorted lang yun mangyayari, no? When you reverse, no? Pag pinagbaliktad mo yung connection ng dalawang coil, you can produce a short circuit. See? There's no line 1, line 2 connected to each other. There is none. But if you connect in this manner the two transformer coil, that is just equivalent to this short circuit. That is the importance of the transformer polarity. If you connect it wrongfully, no, in a wrong manner, like this one, you may produce a 0 volt, and that is a short circuit. Kasabog yan. Then, what is the next question then? The next question is, saan ginagamit? What is the function? Para saan yun, sabi nga. What is the function? The function is, let's say you connect two transformer in parallel. That is the function. Where when can we use? Or first, shall we say, if we want to increase the voltage or reduce the voltage, that is possibility. Voltage variation, let's say. We want to increase or decrease the voltage. Voltage variation. That is one use of the transformer polarity. The other use is what? When you connect the transformer in parallel. Transformer in parallel. And lastly, transformer polarity is very important. When you connect the transformer in three-phase connection, it's very important. Three-phase connection. Napakahalaga ng transformer polarity. Pag nagkamali ka ng connect yan, ibang voltahe output mo. The worst is mag-short circuit pa yan. No? Nakukuha po ba? Nag-gets po ba yun? No? Ganun po. No? Well, actually, my answer is not yet complete. See? But I can't make it in the fullest detail. That's too long. Maybe I could show you some pictures, some diagrams, no, to prove. Okay, but we have no more. We don't have a luxury of time. So, well, that is my answer to that question. Okay. I think that is our last question, right, partner? So maybe I could answer around 2. Let's have a bit of overtime, no? Meron bang nagtanong sa kanilang ano? Ito muna ipapakita. Meron bang ano? Yan muna. Meron pang iba ng tanong? Next na lang. Ha? Okay. Yung unang tanong. Siya lang yung nagtanong. Okay, there is a question. This is a live question, no? So, of course, Sir Peter is connected, but magbanwa. Okay, pakita natin, partner. Highlight mo, 50-50. Okay, good evening, Sir Peter. Ka-Peter, magandang araw sa'yo.
Good evening, Kuya Rex.
Okay, I think you have 2 questions, right, partner? Okay, I'll be answering this on spontaneous, live. No? Okay, so his question is the phase rotation the same as the phase sequence? The answer is yes. The phase rotation is just the same as the phase sequence. Okay, so that is my answer. And another question, Sir Peter. Okay, this is his question. What is that? Actually, ngayon ko palang mababasa itong tanong mo, sir. Ha? So, ano ba ang tanong niya? So, if the transformer has a polarity, then what happens if the polarity of the transformer is changed? What does it? The polarity of the transformer is changed or change connection? Actually, I already answered this question. So, what do you mean? Hello, Sir Peter. What do you mean? What happens if the polarity of a transformer is changed? What? So that I can answer you as honest as I can. What do you mean by this?
Actually, sir, doon.
Okay, mga kawerpa, ha? Magandang gabi po, no? Tuloy-tuloy po ang ating REE and RNE mentoring. Meron lamang po tayong isang live audience na katanungan, no? If the galing kay Sir Peter, magbanwa po ito. If the transformer has a polarity, then what happens if the polarity of a transformer is changed? No? I just want to clarify this. No? If you can speak in English, that's better, Sir Peter, so that our non-Filipino audience may understand this discussion. So, preferably, let's speak in English as much as we can. Okay. So, what happened if the polarity of a transformer is changed? What do you mean polarity of the transformer is changed? Change in connection? Is that
No. Actually, sir, if the polarity of the transformer is accidentally changed, the transformer, sir, that's what I mean. No?
Accidentally change? What do you mean change? Change in its connection on the way you connect?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Well, actually, I answered it already in my discussion. So when you accidentally change its just like this basic example, because this two coil has 110 volts, 110 volts rating. No? Connect it this way. Just like two batteries, you connect this way, the two battery. It's just the same principle. You will come up with a 0 volt. No? They are opposing to each other. Magka-kontra sila. No? I already proved this using the Kirchhoff's voltage law here. So you will see here that the two battery opposes, or this represents the transformer coil here. If you connect it wrongfully, the worst case is you will come up with a short circuit. Even when you connect a transformer in parallel, you should connect H1 to H1 of the other transformer, H2 to H2 of the other transformer on the primary side, let's say. And the secondary side, let's say you want to parallel two transformer. You have to connect X1 of transformer 1 and X1 of transformer 2. Not X2, not X2, that may be shorted. Well, it depends on the voltage distribution of the coil. But if you are to connect transformer in parallel, it should be H1 to H1 of the other transformer. I mean, you have two transformers. Try to imagine you have two transformers. X1 of transformer 1 must be connected to X1 of transformer 2. X2 of transformer 1 must be connected to X2 of transformer 2. Well, if you are connecting a three-phase, making a three-phase connection, that's another thing. You have to connect. Well, I have some diagram of three-phase connection of transformer. No? Maybe we could share that with you next meeting, partner. No? If you want to explore on this, I may share this with you. I have a diagram on. Well, anyway, you can also see those diagrams in books, even in Google. No, you can take a look at the you type three-phase transformer connection. There you will see H1, H2, H3. See X1, X2, X3. That there is a consideration on the transformer polarity. Because if you make a wrong connection, you will come up with a wrong output voltage. That is the effect. Okay, Sir Peter?
Thank you, sir. Thank you, sir.
Okay, clear po ba tayo doon? Okay, is that clear?
Yes, sir. Thank you.
Okay, thank you, thank you. Is there another question, partner? No more question. Okay, so thank you. Okay, mga kawerpa, no? Magandang gabing muli sa inyong lahat, no? Live na live po tayo ngayon, mga kawerpa, dito po sa Marinais Powerhouse Team Review and Training Center. Okay, may mga ilang lamang po tayo babanggitin, mga kawerpa. Patungkol po sa mga comment, no? Let's punta tayo sa ating mga social media reaction, partner. Okay, basahin natin ang ating mga social media reaction. Galing kay Sir Peter Magbanwa na to, no? Okay. So, thanks for the detailed explanation. Basing on different situation, may power talaga sa powerhouse. Kahit sa power room ka lang nanonood with Kawerpa Kuya Rez and his powerful stuff. Galing kay Aristelo Silva, best tutorial. If you are an electrical practitioner, very informative, the format is very good. Keep up the good work, Sir Reggie. Galing kay Gian Cuenca. Salamat Kuya Reggie sa pagkoconduct ng ganitong pre-webinar. Sobrang dami naming matututunan dito. Galing kay John Adrian Galang. Ang peer mag-explain ni Sir recommended para sa mga beginners sa construction. Galing kay Junel Asuncion Monroy. Sir, maraming salamat po sa mga lesson ngayon. You explain it very well po and I find it very entertaining lalo na po kapag nagkukwento ka tungkol sa mga na-experience mo po. God bless po and more power. Galing kay Junkel Levantino. Salamat po sa video na to. Ngayon lang ata nagkaroon ng EE topic tutorial na Pinoy ang nagle-lecture. Di magtatagal, dadami na subscriber niyo po. Thank you. Galing kay Rodney Barosa. Thank you so much, Marinay Powerhouse team. Very clear discussion and informative for me. Keep it up. God bless. Galing kay John Burr Bacaro. Very good topic. Napakaganda talaga ng produkto ng Powerhouse. Thank you, Powerhouse team, for always sharing your knowledge. Galing kay Jan Lumanggaya. Okay, sobrang solid ng pre-webinar na to. Smooth lang yung explanation. Mabilis lang maintindihan ng mga nakikinig. Galing kay Cassandra Faith. Thank you so much, Marinay Powerhouse team, for the pre-webinar. So many ideas and knowledge that I gained on these videos. Keep it up. God bless. Okay. Thanks be to God, mga kawerpa, no? So salamat po sa inyong lahat, no, sa pag-participate nyo. Siya nga pala, no? Meron pa po tayo mga ilang babasahin, mga kawerpa. Separate recording mo. Okay, so I will discuss to you, everyone, our products and services of Marinay's Powerhouse Team Review and Training Center. To all our for all our students, reviewees. Okay. Okay, so we have our free RE and RME mentoring online live via Zoom, no? This is guiding you to pass the board exam and even the college exam, no? So our schedule is every Tuesdays and Thursdays, 5 to 7 p.m. and maybe a little extension about the time, and every Sunday, 11:30 to 1 p.m. No? This is brought to you by UNTV, your public service channel, and Marinay's Powerhouse Team Review and Training Center. Okay, we have a 3-in-1. Again, this is MPHT Review Center. Again, this is in cooperation with UNTV, your public service channel. Okay, so we have a free 3-in-1. This is what we call the free REE review. Actually, partner, meron pa yan, free RME. No? Dapat may slash yan na free REE, RME. So, lalagyan natin yan, partner. No? So, kami po'y magbibigay, mga kawerpa, ng libreng review. Kada Sunday, no, libre po ito. Wala po kayong babayaran, mga kawerpa. Handog sa atin ng UN Television, no? Libreng REE or RME review. Meaning, may mga topic tayo, madi-discuss natin. For halimbawa, today, depende sa subject, no? So, ano yung selected subject, no, na may matutunan po kayo? Okay, inaanyayahan namin kayo this Sunday po, mga kawerpa. Meron tayong libreng REE or RME review. Kasama na rito ang mga special topic. Actually, special topic natin for this Sunday, we'll be discussing the wiring design example from PEC 2017. No? What do I mean? Ito po yung mababasa natin sa likod ng PEC. No? And you will see my my version, no? How I will discuss this. No? Actually, marami na tayong mapapanood niyan sa YouTube, mga kawerpa. No? Pero tingnan natin, no? So baka naman may maitulong din po kami sa inyo, no? So I'm inviting everyone, libre po, pati certificate, no? Yung mentoring natin, kasama rin yan every Sunday, mga kawerpa, no? Via Zoom and via Facebook Live, no? Live na live po tayo. Okay? Ayan po, ang detalye, mga kawerpa, no? Makikita nyo rin sa aming Facebook page yan. Okay? And we are inviting everyone, no? Again, this is a public service from MPHT Review Center, no? Brought to you by UNTV. Okay, this RE and RNE online review scholarship program, review now, pay never, no? Kami lang po ang natatanging review center sa buong Pilipinas na nagbibigay ng scholarship program sa ating mga needy kawerpa, no? Yung ating mga electricians, electrical students, and reviewees, no? Pwede namin kayong mailibre, mga kawerpa, handog sa atin ng UN Television po ito, no? Bilang ka-tie-up po namin sila, no? So, ayan mga kawerpa, meron po tayong actually pang-ilan natin to, pang-apat, no? I think this is already batch 4 of our scholarship orientation, and it will held on December 4, this coming Friday, 5 to 7 p.m. Nanyayaan namin kayo mga kawerpa, yung mga nanonood sa ating Facebook, no? Kung hindi man, i-share po natin ito mga kawerpa sa mga kaibigan, kakilala po natin. Baka meron po tayo mga kaibigan na mga nawalan ng trabaho, mga na-lay off sa trabaho, no? Nahinto ang construction, no? Dito po, pero gustong-gustong mag-exam, especially this coming April 2021, tulungan po namin kayo mga kawerpa, no? Tutulungan din tayo ng UN Television para ma-pursue ninyo ang inyong mga pangarap na lisensya. Ayan, mga kawerpa, this Friday po, alas 5 ng hapon hanggang alas 7 ng hapon, magkita-kita po tayo. Okay, ito po, ngayon lang namin i-announce to mga kawerpa, baka meron po tayo mga kaibigan sa industry na gusto nyo pong ma-promote ng powerhouse, no? Review center, no? Yung inyo pong mga electrical products, no? Kami po'y nananawagan sa inyo. Libre lang po. Wala po kaming i-charge sa inyo kahit 5 regarding po sa pagpo-promote ng inyong produkto, no? Maybe we could start this coming January discussing your products, no? Maganda po ang aming adhikain dito, no? Ang aming tema po dito is bridging the gap between the industry and the academe. Because we believe that there is a big gap between the industry and academe. Now, gusto po namin ma-bridge yung gap na yon, no? Kami maging isa sa maliit na instrumento o tulay para maihatid natin kung ano ba ang latest technology. Malaman kahit na first year pa lang yung bata, dapat involved na yan sa actual, no? Kung ano yung nagaganap sa labas, no? Maintindihan niya. No, by introducing your products, mga kawerpa, baka may mga suppliers tayong nakikinig dyan, partner, no? So, welcome po. Pwede po kayong makipag-tie-up po sa amin. Libre, wala pong charge ito, mga kawerpa. Matutulungan pa po namin kayong ma-promote, no? Every Sunday po, we have a featured electrical products na ipapakita po sa inyo. And it will start on January, no? 2021, no? Pagkatapos ng ating mga PEC discussions. So, isasama na natin yon, partner, no? Sa ating discussion about that will fall on our free webinar. Considered po, i-discuss namin kung ano man produkto meron ka. You have your panel board, circuit breakers, motor controllers, you have your lighting, you have your lightning arresters, whatever electrical products you have, no? Actually, may kausap na po kaming isang supplier po ng mga generators, ATS, no? At saka yung mga switchboard, switch gears. Yan po mga magiging topic natin, no? So, inaayos lamang po namin ito. Kaya kung may nakikinig man tayo, no? May nakikinig po sa ating mga videos na ito, no? Even sa Facebook Live na ating mga electrical suppliers, no? Naanyayahan po namin kayo, no? Tulungan po natin na ma-bridge natin yung gap na yon, no? Matulungan natin yung mga estudyante ma-involve kung ano talaga yung actual, no? Sa actual na nangyayari sa trabaho, makita nila mismo yung device ng actual, o kahit sabihin natin Sa pamamagitan lang ng mga pictures na ipapadala nyo na actual, no? Pag-usapan po natin, mga kawerpa, wala pong i-charge ang powerhouse po sa inyo. It's just that gusto lamang po namin makatulong din sa ating mga estudyante at sa ating mga kawerpang mga license o hindi license na mga electrical practitioners, no? So every Sunday po, i-discuss namin ang inyong mga produkto starting this January. Okay? This is bridging the gap between the academe and the industry. Okay, we have the online review program, special promo po namin mga kawerpa, extended po hanggang December 3, no? Yung RE review course namin is 9,000 pesos. No? This is online review via Zoom, mga kawerpa. Ang ating refresher is 8,000, no? Yung ating pong review and refresher, mas makakatipid kayo dito, mga kawerpa, no? So, makakatipid kayo ng 4,000 pesos, bali 13,000 lang ang babayaran nyo, no? Review and refresher course na po yan, no? Sa ating mga master naman, no? Okay? Yung ating RME, no? This Sunday na magsisimula ito, no? Yung aming pong Master Electrician Review. Okay? RME review course is 8,000 pesos lang. And refresher po namin is 7,000. That is 15,000. Pero, kung magbabayad ka on or before December 3, you will just pay only, how much is this? You will just pay, hindi partner, 12,000 yun, save 3,000. So, okay po, mga kawerpa, 12,000 po yan, no? Save 3,000 pesos. Okay? Ayan, sige, update natin yan, partner. Okay, next po. Yung ating naman po mga special webinar, magsisimula na tayo. This coming Monday, December 7, baka may gusto pong umattend ng building wiring installation. This is leading to NC2, no? Test the NC2. Makakatulong din po sa inyo to, no? Na lectures na ito, no? Kung kayo po'y magte-take ng NC2 ng TESDA. So we are inviting you to attend our special seminar or webinar this coming Monday. Makakatulong po sa inyo ito. No? Only 700 pesos. No? This Monday, December 7, 5:30 to 9:30. And yung ating pong industrial motor control, ilan naman yan? December 9. No? So sa gabi po ito, mga kawerpa, yung aming mga special webinar. Only 800 pesos. We have the electrical design course, only 1,500 pesos. We'll be discussing residential, commercial, industrial, up to high-rise building design. So, 1,500 lang mga kawerpa. Then, yung ating practical electrical estimation course, that is only 1,000 pesos. Yung mga gusto pong mangontrata, no? At magkaroon ng idea kung paano ginagawa ng mga electrical contractor, magpresyo, no? O manalo sa bidding, no? Yan ay tuturo po natin yan mga kawerpa, no? Okay? Then we also have a master plumber review, no? Actually, gagawin na po namin ito po pang July mga kawerpa. This for July board exam, no? More or less April po namin sisimulan yan, no? Yung review for master plumber. Okay? Yan po ang mga course outline ng aming mga special webinar. No? Gusto nyo malaman yung exact topic niyan. No? So you can visit our Facebook account. No? Marina's Powerhouse Facebook account. And well, this is our REE review books. No? Ayan po ang 4. Kumpleto na po yan. Math, ESAS, and EE. Computations. So many questions na ating mga sinagutan yan. No? Actually, it's thousands of questions. No? Libo pong mga tanong ang kinompile po namin. It contain the past and possible board exam questions. Ang difference po nito sa ibang reviewer, mga kawerpa, it contains also calculator techniques. No? Yung mga shortcuts, makikita nyo mnemonics, no? Makikita nyo yung pinakamadaling paraan ng pagsosolve ng mga problems, no? Para sa ating mga kawerpang EE. Diyan, no? Then, para sa ating mga master naman, okay, yan pala ang ating mga bumili ng ating mga libro, okay, sa REE. O sa ating mga master naman po, yung 4 po na libro na yan, no? So, Kumbaga, malaking tulong po ito kung meron kayo ng 4 na libro na to, tapos nag-enroll pa kayo ng review program namin, no? Malaki na po, napakalaki na po ng chance ninyong pumasa na kayo sa board exam, no? So itong 4 na libro lang na to, no? Plus, mag-attend lang kayo ng review program namin online, nasa bahay lang naman tayo, kahit saan ka sa Pilipinas, even sa mundo, partner, no? Kasi tayo'y online via Zoom. Okay? So, pag-isipan nyo mga kawerpa, no, na ating mga electrician, this Sunday na po ang start ng ating R&E review. Okay? Yan na po ang mga bumili ng ating mga review books. No? Then, Master Plumber books, meron din po tayo mga kawerpa. Ayan po ang ating mga libro sa Master Plumber. Okay? Kung interested kayo sa mga libro namin, kontakin nyo lang po kami sa Marinais Powerhouse Messenger account. Or pwede nyo rin naman po kaming i-text sa 0922-247-3137. O sa aming Facebook, Marinais Powerhouse. No? Okay? Ayan. So, ito po ang aking YouTube channel. Baka hindi pa po kayo subscriber. No? So, please subscribe to my YouTube channel. No? So, hindi pa po ganun kadami yung ating subscriber. Pero, thank God na tayo po'y monetize na, mga kawerpa. We already have more than 1,600 subscribers and more than 9,000 views. No? So, sana ano nyo po ito, subscribe, mag-comment din po kayo, like and share this channel. And we see to it that you will learn a lot from this channel. No? Marami po kayong matututunan sa channel po na ito. Okay? Even to our licensed electrical practitioners, no, makakatulong po ito sa inyong pag-recap, pagre-review, no, yung mga REEs natin na gustong mag-PEE, no, kasi ang PEE licensure exam natin ay meron din naman pong theoretical exam na binibigay ang ating mga examiner. No, makakatulong po sa inyo mga lectures po namin dito. Libre naman, you can download and sana wag lang kalimutan i-share. At siya nga pala mga kawerpa, baka naman pwedeng panoorin nyo yung commercial na lumalabas sa aming video, no? Malaking tulong nyo na po sa amin yun. Segundo lang naman po, maliit na bagay, saglit lang, no? Kumpara sa 2-3 oras kada video na mapapanood nyo, no? So, ayan po mga kawerpa. Okay? That's it for today. Maraming salamat po sa inyong lahat. We have quite a long day today. Maraming salamat po. So, makita-kita tayo muli mga kawerpa sa araw ng Huwebes, no? 5 to 7 p.m. again. No? And please expect, mas maganda, mag-expect na tayo ng extension mga kawerpa. No? Okay? So, maraming salamat po. God bless you all. Stay safe mga kawerpa. Thank you.